All right, everybody. Now we're going to talk about rotations. Think about some things in the world that rotate. I think about tires. I think about the hands of a clock and how they rotate in a circular direction. So a rotation is a transformation that turns an image around a given point. Okay, sometimes we're going to turn or rotate around the origin, and sometimes you might have to rotate around a different point or another point somewhere on the coordinate plane. So remember, it's important to read carefully. So here we have a pre-image. Let's go ahead and write down our ordered pairs. G is at -4, 5. H is at -3, 5. I is at -5, 1. And J is at -2, 1. Again, I grabbed a piece of my tissue paper, and I'm going to go ahead and trace this again. Trace this shape. Now, it's really important for this time that we label all points. The reason we have to label them is because your points are going to move. And this time we are going to rotate around the origin. So we want to keep the origin in its place. So we are going to rotate it clockwise, 1 turn. Now, how many degrees did we turn it in this case? We went from here to here, and we know that a right angle has 90 degrees. So we are going to turn it 90 degrees. You can also turn a shape all the way around 180 degrees, because that would be 2 right angles. You can even turn it 270 degrees, and do you see how the origin stays in its place? Okay, so it's important that you first of all, turn in the right direction or in the direction that it states, or you specify when you're describing it that you specify the direction that you're going, as well as the number of degrees. How far are you turning it? So here, this trapezoid was rotated 90 degrees clockwise. And it was around the origin because the origin stayed in the same place. That was the point that stayed, that was consistent. All right, so once we do that, let's write down now we have G prime. Let's write down the coordinates there. It's at 5, 4. H prime is at 5, 3. I prime is at 1, 5. And J prime is at 1, 2. Pause the video and take a minute to see if you can see a relationship between these points and these points. Okay, hopefully you noticed that there was a pattern that occurred. We can see that our X value here is the same as the Y value in our pre-image. And what happened to the Y value? Well, the X value became the Y value, but it became its opposite. And that was when we turned it 90 degrees. So let's, just to make sure that all of our notes are complete, if a shape turns in this direction, that is called clockwise. And if a shape turns in this direction, it's called counterclockwise. Direction is very important when we're talking about rotations. We all know that this is the origin, and the name of that ordered pair is 0, 0. And here are diagrams to show how far a rotation can occur. Actually, a rotation can occur at any number, but in 8th grade, we're going to focus on using right angles. So in this case, this is 90 degrees. The distance of a semicircle is 180 degrees. And if you were to go 3 right angles, that would be 270 degrees. So, again, think about what happened to our shape. Did the size or the shape change? Nope. So again, this creates a congruent shape. It's the same size and the same shape, and it is still considered a rigid transformation. A rigid transformation, remember, means that it didn't stretch and get bigger and didn't shrink and get smaller. The size stayed the same. We noticed some patterns up here when we were looking at the ordered pairs. So let's see what the algebraic representation looks like when we do rotate a shape. If we rotate a shape 90 degrees clockwise, and you have xy, we noticed that your y value became the x value. So in this case, since our y is -7, that's now going to be our x value. And our x value is going to become the y value, but it's the opposite. So we're going to take the opposite of the x value for the y. Okay? I'd encourage you to, again, take a coordinate plane and print one from Schoology and create a shape and give this a try, just to practice and see if you get the correct coordinates. Also remember, using a piece of paper, of tissue paper, can be very helpful as well. So if we were going to rotate a shape 180 degrees so that it turns all the way around, and you start with x and y, it basically takes, let's look at how this is going to change. Instead of being where you have two, a negative and a positive ordered pair here, now we would have our x would be positive and our y would be negative, because it puts it in the quadrant that is catty corner to it. So in this case, we would end up with the opposite of 3 is -3, and the opposite of -7 is +7. Give that a try on your coordinate plane. If we were going to rotate 270 degrees clockwise, that means we would take this shape and go 3 right angles. 1, 2, 3. So instead of being, in this case, in the second quadrant, we would now be in the third quadrant. So this time, our x is going to jump to our y value. So now our y value is going to be 3, and we'll take the opposite of y, and that becomes our x value. So in this case, instead of -7 being our y value, 7 will be our x value, and our y value is 3. Again, give that a try. Now you'll notice that if we had, how else could we have changed or turned this shape to get it to go 270 degrees clockwise? We could also rotate it counterclockwise only 90 degrees. So that could also describe this shape. We would get the same result just going 90 degrees counterclockwise as opposed to 270 degrees clockwise. Play with this and look for those connections. See if you can see how the numbers are changing.